Hello and welcome everyone. Thank you for joining us. Today we're going to take a fresh look at Oracle Database Appliance, or sometimes we call it ODA. Many of you already know ODA as an appliance for Oracle Database. That's how it started, but it continues to be one of the simplest way to deploy Oracle databases. But now, the Oracle Database Appliance is much more than just a database appliance. And as more companies modernize their database infrastructure, and they are now starting to use enterprise AI, it is a good time to rediscover everything that the Oracle Database Appliance can offer you today. So let's go ahead and get started. When customers hear Oracle Database Appliance, they immediately think of Oracle Database, and that's exactly where the story begins. When we first introduced ODA, the goal was simple: make Oracle Database deployment and management easier. Customers wanted the performance and reliability of Oracle Database without spending weeks integrating servers, storage, networking, the operating system, and other components. Instead, they received a complete platform that was engineered by Oracle, and everything was designed, integrated, tested, and supported as a single system. That's what made the Oracle Database Appliance different. It allowed customers to deploy faster, simplify operations, and focus on running their business instead of building infrastructure. As customer requirements evolved, so did the Oracle Database Appliance. Company wanted to consolidate applications alongside their databases right next to each other to reduce infrastructure costs and to simplify management. In response, we integrated virtualization, allowing databases and applications to run together on the same platform and at the same time maintain the simplicity customers expected from the Oracle Database Appliance. And now we're seeing another shift. Customers are telling us we want to bring AI closer to my enterprise data. They want to build intelligent applications while keeping their data secure and highly available. So that's where Oracle AI Database comes in. Capabilities such as vector search, RAG, and AI-powered database features all depend on trusted enterprise data running on a secure and highly available platform. And the Oracle Database Appliance brings those capabilities together in a single engineered system. So today I'm not going to dive into the AI technologies. Our Oracle AI Database experts are going to cover the AI capabilities built into the Oracle Database. My goal is to show you how Oracle Database Appliance provides the foundation that brings database, virtualization, and Oracle AI Database capabilities together. Every major evolution of the Oracle Database Appliance has been driven by changing customer needs, customer requirements, from simplifying database deployments to consolidating applications, and now they want to enable enterprise AI. So with that in mind, let's begin by looking at the Oracle Database Appliance vision. Oracle Database Appliance has evolved over the years, but the principles behind it have remained the same. Everything we built into the Oracle Database Appliance is guided by these three core principles. The first one is simplicity. From day one, the goal has been to make the Oracle database as easy as possible to deploy, manage, and maintain. We automate deployment, patching, upgrades, and day-to-day operations so that customers spend less time managing infrastructure and more time focusing on the applications and their business. And whether you're deploying a new system or if you're maintaining an existing system, the experience should be simple and consistent. The second is reliability and security. So enterprise databases support business critical applications. That's why availability is essential. Customers expect their systems to stay online during hardware failures. If you have a planned maintenance, or you're doing a software update, or due to changing security requirements. The Oracle Database Appliance is designed to provide a resilient, secure platform that is easy to maintain. And the third one is low cost of ownership. This goes beyond the initial purchase price. It is about reducing the time and effort required to deploy, manage, and maintain the platform. It's about reducing downtime, eliminating infrastructure integration work, and simplifying day-to-day administration. It is also about software licensing. Customers have asked us for more flexibility in how they license the Oracle database, and we've continued to expand the licensing options that are available in the Oracle Database Appliance. And the result is a platform that is easier to manage and more cost-effective to operate. And as we go through today's session, you're going to see that every feature that we discuss supports one or more of these three design principles. Let's start with the first design principle, simplicity. Oracle Database Appliance automates many of the tasks that database administrators and infrastructure teams would otherwise perform manually. The goal is to remove operational complexity. To see what that means, let's compare the Oracle Database Appliance with a traditional enterprise database platform. Let's look at a typical multi-vendor platform. Every database needs a complete technology stack to run. That includes storage, servers, device drivers, operating system, and the virtualization layer. And if you're running Oracle RAC or real application clusters, you'll also need Oracle Clusterware and a cluster file system for sharing data across the cluster. Then there's the database itself, and finally, the tools used to automate the database operations. At a minimum, you're going to be working with 3 or 4 vendors, sometimes more. And of course, Oracle is going to be one of them. And that means someone has to integrate all of those components. They're going to need to validate the compatibility, test every update, tune performance, maintain security, and when issues happen, they're going to need to troubleshoot those issues when something goes wrong. And usually that someone is going to be the customer. And that's time that customers could be spending on their applications instead of the infrastructure. And most of us have been on support calls with multiple vendors where every team is trying to determine who's responsible for the problem. It's not easy, and they're going to be pointing fingers. And this isn't just frustrating, it increases operational risk. Every customization introduces another variable. Every software update requires another round of validation. Every additional vendor that comes in makes support more complicated. That is the complexity that Oracle wanted to eliminate with the design of the Oracle Database Appliance. And we're going to take a look in more detail as to what the Oracle Database Appliance offers. Now let's compare that with the Oracle Database Appliance. Instead of assembling the technology stack from multiple vendors, Oracle Database Appliance provides a complete platform that is engineered by Oracle. Oracle designs the hardware, develops Oracle Linux, Oracle Clusterware, and Oracle Database, and also validates the firmware, operating system, storage, networking, and database software together. Everything is engineered to work as a single system with the Oracle Database at the center. That's one of Oracle Database Appliance's biggest advantages. Customers are not starting with individual components that still need to be integrated and validated. They are deploying a platform that is already been engineered, optimized, tested, and fully supported as a complete system. For a customer, that changes day-to-day operations. Deployment is faster because much of the integration work has already been done. Patching becomes more predictable because Oracle validates the complete software stack before you receive it. Performance starts from an optimized baseline instead of a custom-built environment. And support is simpler because a single engineering organization is responsible for the entire solution. Another important advantage is what I like to call the community effect. Thousands of customers are running essentially the same engineered platform. That means Oracle gains experience from a broad installed base and continuously improves the platform. When we identify an optimization or improve automation or address an issue, those improvements can be delivered to every customer running the Oracle Database Appliance. Instead of every customer solving the same integration problem independently, Oracle solves it once and makes that improvement available across the installed base. That's the value of an engineered system. It's not just about simplifying deployment, it's about simplifying the entire operational experience. Let's compare these multi-vendor systems to the Oracle Database Appliance. We have automation across the full stack, including installation and updates. This also includes creation of databases that are properly configured for high performance. Real application clusters is critical for high availability, and ODA makes it simple. It's all integrated. Automation simplifies configuration of DataGuard for disaster recovery. We have security hardening of the full stack like OS, drivers, and database. We have automation to make virtual machines easier to create and manage. We have virtual machines for databases and applications. Clones are automated and database aware. And of course, you're going to need diagnostics and phone home to keep the machine running. And remember, right, that Oracle Engineering tests and certifies the complete hardware and software stack. All the Oracle best practices are built directly into the platform. At the end of the day, the result for database administrators is that they're going to be spending less time on routine operational work and more time delivering value to the business. And as companies deploy more databases, and remember that they are also increasingly deploying more AI workloads, that operational efficiency is going to become more important. Automation simplifies operations, but enterprise infrastructure also has to be resilient. Databases support business-critical applications and increasingly AI workloads. Let's look at how Oracle Database Appliance delivers high availability, disaster recovery, and full-stack security. Start with local high availability. The Oracle Database Appliance high availability model combines two servers with shared storage to create a highly available database platform. Oracle Real Application Clusters, or Oracle RAC, is built in, making it easy to deploy and manage highly available databases. If a server, operating system, virtual machine, or database instance fails, the workloads automatically continue running on the surviving server. And during planned maintenance, workloads can be moved between servers with minimal disruption, helping keep applications available while maintenance is performed. Oracle Database Appliance also supports Enterprise Edition high availability, and this gives customers another option for protecting single instance Enterprise Edition databases. And because Oracle Real Application Cluster is built in, workloads can also scale across both servers when additional capacity is needed. The key takeaway is simple. Oracle has removed much of the complexity from deploying and managing highly available databases, allowing customers to focus on keeping their applications available instead of managing the underlying infrastructure. Remember that local high availability is going to protect against component failures, and disaster recovery protects against much larger events. In this slide, we're going to take a look at how the Oracle Database Appliance simplifies disaster recovery with Oracle DataGuard. Oracle DataGuard is a proven technology that replicates data between systems to help protect against site failures and major disruptions. And typically, these systems are going to deploy in separate locations, providing protection against disasters, power outages, data corruption, server failures, and other events that could impact the entire site. Oracle Database Appliance simplifies the deployment and management of Oracle DataGuard, making disaster recovery easier to implement and maintain. Now, the recommended architecture is very simple. At the top of the slide, you see the Oracle Database Appliance HA, or High Availability Model. Just implement one at each site, and then set up disaster recovery between those two systems. And together, they're going to give you protection against any local failure and also any site-wide outage. But now, if your environment doesn't require the ODA HA model, You can also set up data guard with the small or the large models, as you see here at the bottom of the slide. Security is highly important for everyone. We spent a lot of time in development effort taking care of security in the Oracle Database Appliance, including the full stack. We start with in-house designed servers. We add Oracle Linux configured for the best security possible. We follow the industry-leading best practice of least privilege. And to minimize the attack surface, we only include only the necessary operating system packages. And of course, Oracle Database Appliance can use all database security features, which include encryption, audit vault, database firewall, and database vault. And finally, we provide timely updates for the full stack. Updates to the full stack are tested and certified by Oracle before each release. Instead of assembling patches from multiple vendors and hoping they work together, customers receive updates that Oracle has already tested as an integrated system. And as organizations begin deploying AI on enterprise data, this becomes even more important. If you want to trust AI, you first need to trust the data and the platform behind it. The third design principle is cost. When people hear lower cost, they often think about hardware. In reality, hardware is only part of the equation. For enterprise database platform, much of the cost comes from everything around the hardware: administration, downtime, infrastructure software, database licensing, operational risk, ongoing maintenance, etc. ODA helps reduce costs across all those areas. The next few slides focus on total cost of ownership, not simply the purchase price. We already saw that Oracle Database Appliance includes the full stack, so now let's talk about why this leads to lower cost. You're only paying for the Oracle Database Appliance and database licenses. You get with it virtual machine software, highly secure Oracle Linux operating system, industry-leading clusterware software, cluster file system, storage cloning to make copies of data, and all the automation. And once again, testing, certification, security hardening, and regular patches for the full stack are included. For customers, that means less time integrating infrastructure, less time testing updates, and more time delivering database services to the business. Oracle Database Appliance isn't just bundling software, it's helping you reduce your operational effort. Oracle Database Appliance is engineered for low cost. Most of the savings come after the deployment. Availability reduces the business impact of outages. Automation reduces repetitive administrative work. Standardization simplifies troubleshooting and lifecycle management. A good example is hybrid columnar compression, or HCC. For analytic workloads, HCC can significantly reduce storage requirements by up to 10x and improve scan performance by up to 10x as well. That means less storage, better query performance, and lower infrastructure costs. When you combine automation, engineer reliability, storage efficiency, and simpler administration, you reduce operational costs across multiple areas. That's why Oracle focuses on total cost of ownership instead of the initial purchase price. For many customers, database licensing represents a larger investment than the hardware. That's why capacity on demand is one of Oracle Database Appliance's most valuable capabilities. Traditional infrastructure often requires licensing every processor in the server, whether you need that capacity or not. With Oracle Database Appliance, customers license only the processor cores that they need today. And as workloads grow, additional cores can be enabled incrementally. That allows licensing to grow with the business instead of paying for future capacity upfront. And for many organizations, the licensing savings alone can offset a significant portion or even all of the hardware investment. From this graphic, you can see the cost savings in just a 4-year period. It is common for customers to see 70% lower licensing costs using capacity on demand. Oracle Database Appliance also includes licensing advantages that are not available on generic systems. For customers using Oracle Database Standard Edition 2, ODA uniquely supports deployment on AMD processors, with multi-chip module architectures while preserving standard edition to licensing eligibility. And ODA also allows standard edition and enterprise edition databases to coexist in the same system, giving organizations more flexibility as application needs change. And virtualization provides another advantage. Database licenses can be limited to the virtual machines running Oracle database, and this allows the remaining hardware to run application workloads. Customers can consolidate databases and applications on the same platform and reduce costs. Taken together, these capabilities help reduce the total cost of ownership and give customers more flexibility in how they deploy Oracle database. Let's take a look at the Oracle Database Appliance X11 family. You see here three models: small, large, and HA. And by the way, everything that we've talked about so far is available across all these models. So the family offers three models that are designed for different deployment requirements. The small and the large models are single server system, and the X11HA is a two-node cluster. You can match the size and shape of Oracle Database Appliance to meet your needs. So the small is ideal for smaller environments, branch offices, departmental deployments. It has 32 cores, up to 768 gigabytes of memory, and 13.6 terabytes of SSD storage. And the large provides additional compute memory and storage capacity for larger database environments. It has 64 cores, up to 1.5 terabytes of memory, and up to 54 terabytes of SSD storage. And the HA, or high availability model, provides a two-node cluster configuration with shared storage for customers that need continuous availability using Oracle Regal application clusters or Enterprise Edition high availability. The HA model includes two servers with a total of 128 cores, up to 3 terabytes of memory, and this model can give you up to 369 terabytes of SSD storage or 792 terabytes of disk storage. You're going to have massive amounts of capacity to run databases in the Oracle Database Appliance. And although the systems differ in size and capacity, they all share the same engineering philosophy, the same software stack, same automation, management experience, and the same operational model. And what that means to customers is that you can just choose the model that fits the requirements today while maintaining a consistent operational experience as you grow. So one of the strengths of Oracle Database Appliance has always been the continuous innovation. Since the introduction in 2011, Oracle has continued to invest in both the hardware and the software. If you look across this timeline, you're going to notice that every generation has introduced meaningful enhancement, not just faster processor or larger storage capacity, but improvements across the entire platform. Oracle has increased compute performance, expanded memory and storage, introduced new generations of flash technology, strengthened security, improved high availability, added virtualization, and continuously enhanced lifecycle management. And just as important, Oracle has continuously increased the level of automation. Deployment, provisioning, patching, upgrades, and ongoing maintenance have become simpler. And the result to you is that you're going to spend less time managing the infrastructure and more time focused on the applications and the data that drives the business. And more important than any individual feature is Oracle's ongoing commitment to the platform. Every generation has made the Oracle Database Appliance easier to deploy, simpler to manage, more secure, more resilient, and ready for modern workloads. And today that journey continues with Enterprise AI, ensuring that Oracle Database Appliance remains a modern platform while preserving the simplicity that customers value. Let's take a step back and look at the bigger picture. When Oracle introduced the Oracle Database Appliance in 2011, the goal was simple: make Oracle Database easier to deploy, easier to manage, and easier to support. And that engineering philosophy hasn't changed. What changed is what the platform can do. As customer requirements evolve, also the Oracle Database Appliance evolved from running databases to consolidating applications and now to supporting enterprise AI workloads. And today, Oracle Database Appliance is much more than a database appliance. It's an engineered system that brings together Oracle Database, virtualization, high availability, automation, security, and AI-ready infrastructure in a single Oracle validated platform. So the mission is still the same: simplify deployment and management while delivering enterprise class capabilities. The difference is that today, Oracle Database Appliance supports many more workloads than it did when it was first introduced. So this slide gives you a good sense of how the Oracle Database Appliance is being used today. It is deployed by thousands of organizations around the world, from small and medium-sized businesses running their entire Oracle environment to large enterprises supporting departmental applications, branch offices, manufacturing facilities, and remote locations. Customers use the Oracle Database Appliance for a wide range of workloads, including OLTP, analytics, data warehousing, in-memory databases, and increasingly enterprise AI workloads that rely on trusted enterprise data. And you are also going to find the Oracle Database Appliance across virtually every industry, from financial services and healthcare to manufacturing, retail, communications, education, utilities, and government. And while these organizations are very different, they're looking for many of the same things: performance, availability, and security of Oracle infrastructure without the complexity of doing it themselves. And let me share a few examples of how customers are using the Oracle Database Appliance in their environment. So we have this utility company that migrated from these legacy systems where they were doing production development and testing, and they went to an Oracle Database Appliance for primary production. You can see that they set up DataGuard to another Oracle Database Appliance, and as part of the results, they saw an improved availability with RAC and Active DataGuard. And notice, since this is an energy company with a lot of data that becomes cold at some point, they use hybrid columnar compression to manage the growing data. So this is a feature that is unique to Oracle Engineer System, hybrid columnar compression. And this next example is a financial institution that has Exadata and Oracle Database Appliance in many worldwide offices. Here in the map, you can just see that the main offices are in the United States with large Exadata systems, but then other offices across the world, you can just install Oracle Database Appliances. If there is a need, you can always replicate from those remote offices to the central location in Exadata. And in this example, RAC and Active DataGuard were key applications that were used. And this is another example of a communications company. And you can see here that they went from legacy systems, IBM Sun Microsystems, to 4 Oracle Database Appliance HA systems, and they set up disaster recovery to 2 other Oracle Database Appliances. And notice how they're running these applications. Is Business Suite, homemade applications, which are applications that you can install directly onto the Oracle Database Appliance so that they sit right next to the data. In this case, if you look at the results, it eliminated multiple vendor issues, achieved up to 10 times faster data export. Performance was really good with 2-day jobs completed in hours, and licensing costs were cut by moving from all those older infrastructure to the Oracle Database Appliance. So this is another use case from this public company. You can see that they were running all their business on standard x86 servers, and we see this use case a lot, right? Where customers are running multiple x86 servers and they can just consolidate onto a lesser number of Oracle databases. And in this case, you can see the quote here from their executive. I said, with the appliance architectural design and software capacity on demand, Oracle Database Appliance helped lower the overall TCO. And you can see some of the results here that they were able to achieve with the Oracle Database Appliance. And this is the last example that I want to show you. In some cases, some customers are going to demand an Oracle engineer system that can deliver the highest level of performance, scalability, availability, and that's going to be the Exadata system. So on this one, I want to show you how Exadata and ODA complement each other. Exadata runs the production workload, while the Oracle Database Appliance provides a simple, cost-effective platform for test and training. The customers reduce cost, improve performance, and eliminated downtime during patching. Now I'm going to hand it over to Paul. He's going to cover the next part of the presentation.
Welcome. My name is Paul Cian, and I'm from the ODA product management team. Today, I would like to highlight a number of important areas where Oracle Database Appliance delivers value to our customers. Continuous software innovation, high availability, security, and artificial intelligence. Continuous software innovation means ODA continuously deliver new features and capabilities to our customers through quarterly updates. One of the greatest benefits of Oracle Database Appliance is its continuous software innovation delivered at no additional cost to our customers. With each quarterly update, ODA introduces new features and enhancements that improve performance, security, availability, and operational efficiency. Some of the key capabilities added through these regular ODA software updates include new capabilities that help reduce power usage, strengthen infrastructure protection, and simplify operations. The platform also expands support for modern workloads, including exclusive support for Oracle AI Database 26 AI Standard Edition 2 on AMD MCM systems, KVM virtualization for databases and applications, fast storage efficient cloning for DevOps, and integrated database backup to the cloud. On top of that, ODA integrated key database features like RAG, DataGuard, and TDE, so customers can deploy database high availability and security solutions quickly and easily. ODA also includes exclusive Oracle engineered system features like hypercolumn compression or HCC and Enterprise Edition High Availability or EEHA, while helping customers to better control database licensing costs through capacity on demand. Application and database high availability is extremely important to Oracle customers because the costs of downtime can be very expensive. Oracle Database Appliance is designed for enterprise-class high availability. Its architecture includes redundant power supplies, fans, networking, storage, and servers, which helps eliminate single points of failure. ODA also supports integrated backup and cloud backup, as well as DataGuard for disaster recovery from a standby system. Rolling patching helps minimize downtime during maintenance, and ASR proactively monitors hardware and alerts Oracle support before components fail. Together with integrated RAC and DataGuard, ODA serve as a strong foundation for Oracle's maximum availability architecture. The ODA high availability system provides built-in protection for both databases and applications. For databases, RAC supports active-active failover in seconds. RAC 1 provides passive failover in minutes. And EEHA offers single-instance database active-passive failover without requiring an additional license. For application virtual machines, ODA automatically restarts a failed VM on the same node or fails it over to the other node if the entire server goes down. The result is a simple integrated platform that protects critical workloads with a minimal manual intervention. Security has always been a core strength of ODA because customers rely on it to run their critical databases. Oracle continues to enhance security through both hardware and software innovations. Security must be addressed across every layer of the technology stack. At the database level, organizations need to protect sensitive data, maintain compliance, monitor privileged users, and audit activities. However, today's threats extend far beyond the operating system. Attackers increasingly target firmware, hardware, and even the supply chain itself. Oracle takes a full stack approach by securing hardware design, manufacturing, software delivery, and firmware updates. Every software components are validated before reaching customers, helping to ensure integrity from factory to deployment. ODA was designed with security and operational simplicity in mind. Because the appliance includes only the software required to run Oracle databases and enterprise applications, the attack surface is significantly smaller than a traditional Linux deployment. Role-based access control allows administrators to separate responsibilities between infrastructure and database teams. The optional transparent data encryption, or TDE, is integrated into the appliance and can be enabled with minimal effort. ODA also supports secure erase using NIST-compliant methods, making it suitable for environments with strict regulatory requirements. Finally, Oracle publishes best practices for ODA and Oracle Key Vault, which allows organizations to centralize encryption management. Security improvements are delivered continuously through ODA software releases. Recent releases have introduced Secure Boot support, Oracle Linux 8 stick support, Oracle Key Vault integration, Secure Linux enforcement, more frequent monthly security updates, and automated system hardening with a security SCAP score over 90. This demonstrates Oracle's commitment to keep ODA secure throughout its life cycle rather than relying only on security at initial deployment. For customers who want additional technical details, Oracle regularly publishes security blogs covering these enhancements. Now let's shift our focus from security to AI. Artificial intelligence is rapidly becoming a core capability for enterprise applications, and Oracle Database Appliance provides an affordable and secure platform for customers who want to deploy AI on-premises. The following slides explain why ODA is an excellent platform for Oracle AI Database 26 AI and private AI deployments. ODA delivers one of the lowest cost entry points to run Oracle AI Database 26 AI on-premise. Customers benefit from lower licensing costs, especially with exclusive Standard Edition 2 support on AMD, along with lower operational costs through appliance automation. ODA is an ideal platform for private AI. Organizations can implement RAG and locally host their LLMs, ensuring sensitive data never leaves their environment. Oracle AI Database uniquely combines traditional relational queries with vector search, allowing applications to mix structured data and semantic search in a single query. Combined with VPD, organizations can build AI applications that are both intelligent and secure. One of ODA's biggest advantages is that customers can leverage unused compute capacity. Instead of purchasing separate AI infrastructure, AI applications and LLMs can run inside secure virtual machines on the same appliance. ODA's integrated KVM virtualization isolates database workloads from AI applications while maintaining strong security boundaries. This approach reduces infrastructure costs, simplifies management, and allows organizations to consolidate both databases and AI workloads onto a single engineered system. Here are a couple of examples of how customers can begin using AI immediately. Oracle AI Database can generate embeddings directly inside the database using SQL and imported Onyx embedding models. This means the documents never need to leave the database during processing. A simple private chatbot like Oracle AI Optimizer can be deployed in less than 10 minutes using RAG with Oracle AI Database acting as the document repository. Oracle has also published demo videos showing how quickly these capabilities can be deployed on ODA. This slide demonstrates how AI can simplify infrastructure management itself for ODA. The KVM Backup and Restore AI Assistant enables administrators to perform backup, restore, snapshot, and VM management tasks using natural language directly from the command line. For customers building AI-enabled development environments, the MCP server integrates ODA infrastructure management with AI coding assistants such as Claude Desktop. Depending on the use case, organizations can choose either the standalone AI assistant for operations team or the NCP server for deeper developer workflow integration.